plot the point 0, -5. So when we're plotting points, we always start at the origin, which is 0, 0. And the x value tells us how far we move left or right. So in this case, we're moving 0 places left or right. So we've taken care of our horizontal move. Now our vertical move is our y, or our range value. And this tells us we move in the negative direction 5 places. So from 0, we move down to -5. So the point here would be 0, -5. So this says fill in the table using this function rule, y equals -5x minus 3. So what we're going to do is take what they've given us in the x column and substitute it in for x in the given rule. So instead of it being y equals -5x minus 3, for the first one, we're going to substitute -2 in for x. So this would be -5 times -2 minus 3. -5 times -2 is +10. And 10 minus 3 is 7. So let's do one more. So the second, we're putting in 0 for x. So again, we come to our original problem, the y equals -5x minus 3. And in place of x, we put in 0. So -5 times 0 is 0. And 0 minus 3 is -3. Our next problem, it says for each ordered pair, determine whether or not it is a solution to 5x plus 7y equals -3. So in order for it to be a solution, when we plug in the given values for x and y, our answer has to be -3 in order for it to be a solution. So let's look at the first ordered pair given, -4 for x and -3 for y, and we come back to the original 5x plus 7y equals -3 and substitute in the given values for each. So the first 5x, instead of x, it's telling us to use -4 plus 7 times the y value. In this case, the y value is -3. So 5 times -4 is -20. 7 times -3 is -21. And when we add the two together, that gives us -41, which is not equal to -3. Therefore, -4, -3 is not a solution. So let's try -2, -1. So again, I'm substituting, in this case, -2 for x and 1 for y. So 5 times -2 is -10. 7 times 1 is 7. And -10 plus 7 is -3. Since the left-hand side equals the right-hand side, yes, that would be a solution. So all you're going to do is plug in the given values for x and y and make sure that the left-hand side equals the right-hand side. If it does, then it is a solution. If it doesn't, then it is not a solution. Our next problem, it says find an ordered pair that is a solution to the equation. So what we can do is choose a value for either x or y, similar to what we did before in making that table, where it gave us a value of x and we found the value of y. So in this case, we can choose anything we want for x or y and solve for the other variable. So let's say, for instance, I want to choose 0 for x. I don't just guess what y is. What I'm going to do is take that value and plug it in for x in the given equation. So now I have 5 times 0 minus y equals 8. 5 times 0 is 0. 0 minus y is negative y. And since I'm solving for positive 1y, I'm going to divide both sides by negative 1. So y would equal negative 8. So that would be a solution. As I said, you could have chosen a value for y. Let's choose any value for y. Let's say 1. It doesn't make a difference what you choose. You come back to the original equation, and in place of y, we're going to put 1. Now we're going to solve the equation. So I need to isolate my variable. And then divide by the coefficient. So x would equal 9/5. So that would also be a solution to the equation. There's an infinite number of possibilities. So you choose whatever you want for x or y and solve for the other. Now, our next problem is to graph the line y equals 2x minus 7. There's a variety of ways to graph. One is to make a table of values, which we'll do for this problem. The other, which is easier, is to use slope-intercept form to graph, and we'll discuss that with the next problem. So in order to make a table for y equals 2x minus 7 and to graph the line, remember, the line represents every possible solution to the equation. So I can choose whatever I want in the table for x or y. Now in this case, if it just gives us y equals, it's easier if we just substitute values in for x. And like I said, you could choose anything you want. I'm going to choose 0, 1, and 2. So one at a time, I'm going to substitute those given values into my equation. So the first would be y equals 2 times 0 minus 7. So 2 times 0 is 0. And 0 minus 7 is negative 7. So I'm going to take my next value, which is 1, and plug it in for x. So now it's y equals 2 times 1 minus 7. 2 times 1 is 2, and 2 minus 7 is negative 5. So that's my second point. You want to do at least 3 points. So the third point would be y equals 2 times 2 in this case, minus 7. So y would equal 4 minus 7, and 4 minus 7 is negative 3. So what we would do is plot each point on our graph. So the first point is 0, negative 7. Our second point is 1, -5. And our third point is 2, -3. So notice they're all on the same line. So now you would connect these points with a straight line, keeping in mind this line goes on forever. So the next method is something called slope-intercept form. So slope-intercept form is in the form of y, so we're solving for y, equals mx plus b. So the m is the coefficient of x, or the value in front of x, and that is our slope. And our slope is the change in the rise over the change in the run. And the last value, this plus b, represents our y-intercept. It's where our graph passes through our y-axis. And that's usually our starting point. So for this particular problem, it's y equals 3/4 x, but notice there's no plus or minus at the end, so that's understood just to be 0. So once we have it in our slope-intercept form, we come to our y-intercept, which is that last value, that constant. In this case, it's 0. So that's our starting point on the y-axis. So I put a point at 0. So my slope is the change as I move from one point to the next. And I say rise over run. So we start at our y-intercept, and our rise is +3. So we initially move up 3 units. We don't put our point there until we do the run. And the run is +4, and +4 means we move to the right 4 units and put our point. Now, if we needed to plot another point, from that point, we do the same thing. We would rise 3 and run 4. And notice again, all these points would fall on the same line. Let's look at the next one. Here, we're asked to graph the line y equals 1/5 x minus 5. So 1/5 would be our slope, and -5 would be our y-intercept. So we come to our y-axis, and we go to -5 and plot our point. Our slope is 1/5. So from there, the change in the rise is 1, so we move up 1. And the change in the run is +5, so from there, we move to the right 5. And again, we can copy that. We can move up 1 and move to the right 5 to plot another point. And again, these are all on the same line. Now let's look at graphing something in function notation. So h of x is the same thing as y. So essentially, we could rewrite this as y equals x minus 7. So our slope is our coefficient of our x, which in this case is understood to be 1. Now, for graphing purposes, it's easier to graph if you write it in the form of a fraction. So we can rewrite 1 as 1 over 1. So our slope is 1, or 1 over 1, and our y-intercept, our starting point, is negative 7. So we come to our y-axis at negative 7. And from there, the change in our rise is 1. So we move up 1. And the change in the run, our denominator, is 1. So we move up 1 and to the right 1. And again, if we want to plot another point, from that point, we move up 1 and to the right 1. And again, draw our line through those 3 points. Let's look at another one. Here we're asked to graph the function f of x equals negative 1/4 x minus 5. So again, we could write this in slope-intercept form. Now, when we talk about a slope being negative 1/4 in this case, the negative does not go with both the numerator and denominator. It goes with either the numerator or the denominator. I went ahead and moved the negative sign to go with the numerator as far as my change. So my slope is negative 1/4. My starting point, my y-intercept, is negative 5. So I come to my y-axis and plot my intercept. And now the slope is negative 1/4. So that means from my starting point, I don't go up, because again, the slope is the change in the rise. If the change in the rise is negative, I move down 1. But my denominator is positive 4, so I'm still moving to the right 4 to put that point. And again, from there, I could do the same thing. I could go down 1 and then to the right 4. So what if something's not in slope-intercept form? You could always use the table, or we could put it in slope-intercept form. So our equation is x minus y equals negative 2. What I do to make it easier is I put the coefficients in front. So if it's missing, of course, it's understood to be a 1 or a negative 1, depending on the sign. And I'm going to solve for y. So that means I need to move the x from the left-hand side to the right-hand side by taking its opposite. And remember, we're solving for positive 1y, so I'm going to divide both sides by negative 1. So a negative over a negative is a positive, so I'm going to leave my slope in the form of a fraction. And a negative over a negative becomes a positive 2 in this case. So my slope is 1, or 1 over 1. And my y-intercept, or my starting point, is positive 2. So I come to positive 2 on my graph. And remember, the slope is the change of the rise over run. So from there, I move up 1 and over 1 to the right. And again, I can do it as many times as I'd like. And then I draw my line that represents all the solutions. Any point on this line is a solution to that equation. The next problem says graph the line y equals 1. So anytime we have a single variable, either x equals, or we can make it y equals, and you don't see the other variable, we don't see an x here, our line is either going to be horizontal or vertical. If our equation is x equals, then we're going to have a vertical line. If it's y equals, we're going to have a horizontal line. So how do we graph this? Now remember what we're asking for when we're graphing. We're asking for all the solutions. Where does y equal positive 1 on our graph? Well, we know y equals positive 1 here, right on the y-axis, but everywhere to the right or left, the value of y is 1. Any point that's 1 unit up from our x-axis is where y would equal 1. And we would have a horizontal line. So let's say it asks us to graph x equals 5. So where does x equal 5? X equals 5 right on the x-axis, but that's not the only place. Any point that's 5 units to the right of our y-axis, the value of x is 5. So it would be a vertical line.